Greetings. This is the Internet Marketing Tool channel. Be sure to hit the like button and subscribe to our channel below.
All right, so this is my chance. Greg's gone, he's out at lunch. But actually, I'm here to talk about TraceRoute. So how does TraceRoute work? TraceRoute is a really useful and interesting tool that you can use to figure out how packets are being transmitted from a source on the internet to a destination. So let's talk about how that works. Here you are, here on your computer, and here is some other computer on the internet. Let's say this is a server that you're communicating with, and you'd like to know how are the packets that are transmitted to the server and potentially from the server, what path are they taking through the internet? So most of the time the internet is just this blob of computers, routers, and the operation of the internet, assuming everything is working properly, is pretty much invisible, and that's good. But sometimes we are just kind of curious, what path are these packets taking? So here's how this works. Within the internet, packets that are transmitted from your computer to this server are going to be touched and transmitted and retransmitted by a variety of different routers along the routing path. So a packet that I sent to this server might go to this router, then be transmitted to this router, to this router, and to this router before finally reaching the server. What I'm interested in knowing is what are the identities of these routers. These routers are addressable. They have to have public IP addresses, otherwise they wouldn't be able to transmit data to each other. So how do I figure out what those IP addresses are? TraceRoute works in this very clever way, and it exploits a field in the IP packet header. So the IP packet includes, along with the destination and the source IP addresses, it also includes this field called the time to live, or TTL. The time to live field is normally used to prevent routing loops. So let's say that there's a misconfiguration in the network and some packet ends up being routed back and forth between these two routers. Unfortunately, if that happens, that packet could just sit there going back and forth forever, consuming network resources, and we can never get rid of this packet. It's never going to get where it's going because there's some sort of routing misconfiguration, but it's also going to be stuck there forever. So the time to live field is used by routers to prevent this from happening. And here's how it works. I initialize the time to live field to some value. 64 is a common value that's used. Every time the router retransmits the packet to another router, it decrements the time to live. So what would happen is this router would see a time to live of 64, it would send it on to this guy who would see a time to live of 63, it would send along to this guy who would see a time to live of 62, etc. And by the time it gets to the destination, maybe the time to live is been decremented by 12 or 13 or 20 or whatever, how many hops it took to get there. Now, normally this all works fine. But the way that this is used to prevent routing loops is if the time to live ever reaches 0, the packet is dropped. So a time to live of 0 means this packet has been transmitted now for maybe 64 hops, and the idea is that that's too many. Something's wrong, the packet isn't making any progress towards its destination, maybe it's stuck in one of these loops, and so the packet is dropped at that point. Now, what TraceRoute does is it exploits this time to live field to find out the identities of the routers along the routing path between a source and a destination. And the way it does this is it uses the ICMP, the Internet Control Message Protocol, because routers can be configured, most routers are configured, to do the following. When a packet expires because the time to live field goes to 0, the router sends a message back to the source saying, oh, by the way, I dropped this packet. Remember, IP's best effort, so there's allowed to drop packets. And all that message does is say, I dropped the packet. So here's what TraceRoute does to find out the identity of these routers. First, and TraceRoute works iteratively, so it starts 1 hop, 2 hops, 3 hops. It's going to try to find this guy first, and then identify this guy, and identify this guy, and keep going all the way to the destination. So the first thing it does is it sends a packet with the time to live of 1. So that packet gets to this router. This router says, uh-oh, the time to live decremented by 1 is 0, so I'm going to drop this packet, but I'm going to send a message back here that says, I dropped the packet. And at that point, this router has identified itself because I look at the source of the message that I get back from this router. And so let's say I found out this is router C. Great, okay. So you might see what we're going to do here. Now what I do is I set the time to live of the packet to be 2. And so router C will route the packet 1 hop forward, decrementing the time to live. But when it gets here, the time to live is 1. The router decrements the time to live, and it says the same thing as the first router. It says, uh-oh, I have to drop this packet. So it sends a message back to the source, and it identifies itself. And traceroute just continues to do this, setting packets toward the destination with incrementally increasing time to live, 1, 2, 3, 4, all the way until it reaches the destination. And in doing so, it can identify potentially all of the routers that are used along a particular routing path. Now there's some caveats here. One important thing is that these routers have to be configured to send these ICMP responses. Not all routers do that. The other thing is the network has to allow those responses to come back. So sometimes when you run a traceroute, you'll see that it stops at some point and then you don't get any more information. And the reason is certain networks block these types of packets. So once I get here, this router doesn't send one, and even if routers farther down the chain try to send one of these I dropped the packet messages back to the source, it's dropped at this network. And so there's cases where you try to run a traceroute, it gets to a certain point, it's going fine, and then you just don't see any more information, and that's why. But this is how traceroute works. It's pretty clever. It exploits the time to live field in order to find out the path between a source and a destination.